let's now take a short look at, I'm just going to sort of try and recap the notes we took on regular polygons. Hopefully that wind howling in the background doesn't bother you. I think it's below 30 degrees outside with the wind chill, which is why I'm glad I'm inside teaching today. But we're going to take a look at polygons and talk about the interior angle sum and the exterior angle sum. And first we have just in general. We basically went through and we looked at, could I come up with a formula for the sum of the interior angles? And when we showed this in class, we looked at, hey, we just proved that the sum of the angles of a triangle is 180 degrees, right? Then we extrapolated this and we said, well, let's look at a quadrilateral. Then we said, let's look at a pentagon. And we went so forth, and we kept making it bigger and bigger and bigger. But we noticed, like, we didn't have a formula for this, but I could say, hey, can I divide this up into some triangles? And this angle, these two angles make up that one. This angle and these two angles make up that angle. The sum of these angles is 180. The sum of these angles is 180. And then this was 360 degrees, because we just added 180 and 180 again. And we did the same thing here. Can we divide this pentagon up into some non-overlapping triangles? In this case, we got 3 of them, right? And we said, all right, well, 3 times 180 is 540 degrees. And if we wanted the angle sum, this is the interior angle sum, it was always however many triangles I could get times 180. And we noticed if it was 3 sides, there was 1 triangle. If there was 4 sides, there was 2 triangles. If there was 5 sides, there was 3 triangles. And we kept going and going and going. And we noticed, hey, the number of triangles is always 2 less than whatever the number of sides is. And that's where we got this formula, n minus 2 times 180. N being the number of sides. So this could be a problem like, what is the sum of the interior angles of a, 12-sided figure? So if I said, what is the sum of the interior angles of a dodecagon, which is a 12-sided figure? So in this case, n is 12, so we just simply say, all right, the sum equals 12 minus 2 times 180. 12 minus 2 is 10. 10 times 180 is 1800. So the sum of the interior angles of a dodecagon, 1800. We wanted the sum of the exterior angles. So again, that's the formula for sum of the interior angles. Any polygon. 60 sides, plug in 60 for n. 120 sides, plug in 120 for n. When we looked at the exterior angles, and this is something we looked at in class today, the sum of the exterior angles, 1 at each vertex, is 360 degrees, period, no matter how many sides a figure has. So 3 sides, sum of the exterior angles is 360. 72 sides, sum of the exterior angles is 360. Again, and these are just polygons where we don't know anything specific about their interior angles or their exterior angles. Now, we took this a step further and we said, well, let's look at regular polygons. And more importantly, all the polygons we're looking at are called convex polygons. It makes all the formulas we look at rather nice when we talk about finding one interior angle and one exterior angle in a regular polygon. So these are regular convex polygons. What makes a polygon regular? Has a lot of fiber in its diet? Doubtful. No. A regular polygon is a polygon that has all sides congruent and all angles congruent. We basically call that equilateral, all sides congruent, equiangular, all angles congruent. Now if I wanted one interior angle, I could take the sum and divide it by the number of interior angles. Well, if it's a triangle, there's 3 angles in the inside. If it's a pentagon, there's 5 angles. So the number of angles is equal to the number of sides. So if I said, what's one interior angle? It's this formula, n minus 2 times 180 divided by n, gives us one of those, and again, they're all equal. So if it was a quadrilateral, it would be 4 minus 2, which is 2, times 180, which is 360, divided by 4, which is 90. All the angles in an equilateral, equiangular quadrilateral, which hence is a square, all the angles would be 90. Now if I wanted one exterior angle, that's equal to 360 over n. Again, if I look at both of those formulas, to me, which one would I rather use?
May I have your attention, please? Brandon Mendez, please report to the South Main office. Brandon Mendez to the South Main office.
And I know if I was in middle school, everyone would be like, ooh. That's what we always did whenever somebody got called to the main office. I don't know why. But anyway, he's probably not in trouble since we're after school. If I look at these two formulas and I said, which one of these is the one I would want to deal with? This one. There's not a whole lot going on. Exterior angle, 360 divided by n. This one, n minus 2 in parentheses. Not saying you can't use both, but it's real easy to look at them and say, this is the easier one to set up and solve for. Knowing that, what's the relationship between an interior angle and an exterior angle? They're supplementary, right? Interior angle and exterior angle are supplementary, meaning they add up to 180. So if I have a little chart, we looked at these charts where, hey, they gave me the number of sides, find the interior and exterior. They gave me the interior angle, find the other two. So again, now if I wanted to find the number of sides, I could take this problem and solve it for n. Now I could show you algebraically. Like if I had this a equals 2 over b, and I said solve that for b. Probably in algebra 1 you would have been like, alright, if I'm going to solve this for b, I'm going to multiply both sides by b. That's going to give me ab equals 2 because they cancel out. And then I want to get b by itself, so I would divide both sides by a. So b is equal to 2 over a. And if I look at what I started with, the only thing that changed from here down to here was the a and the b switched. Now, that actually happens to be a property of proportions. And if I have two ratios that are equal, so again, I'll use the same example. If I said a over 1 equals 2 over b, one of the properties of proportions was that you could switch diagonally, meaning a numerator and a denominator of one ratio to the other, and it would still be equal. And that's what property we're basically going to use here to say, hey, if one exterior angle is equal to 360 divided by n, then the number of sides is equal to 360 divided by an exterior angle. Again, only in regular polygons. So we'll wrap this up. I'm going to put a couple examples on the board to go through, and then we'll be done.